Here we have a kinematics of circular motion question. So pause the video, take a look, and we'll get right into it. So part A of our question is asking for the angular speed in radians per second of the spin cycle when we open the lid. What I'm going to use here is a technique called dimensional analysis. If I'm given units of revolutions per second, and I want my answer to be in radians per second, I need to multiply by units of radians per revolution. And I just have to put that ratio together. So we know that there's 2 pi radians per 1 revolution. The revolution units cancel. I end up with the proper units of radians per second, and I simply have to carry out the task of multiplying 5 times 2 pi. So omega equals 31.4 radians per second. Once the lid is opened, we will have a slowing down from an angular speed of 31.4 radians per second to a final angular velocity of 0 radians per second. This occurs over 12 seconds with a constant angular acceleration. So we can use our kinematics equations for circular motion to solve for alpha. And doing so, we find that alpha equals negative 2.62 radians per second squared. The negative value making sense because we had a slowing down of our angular speed. Now, in order to determine through how many revolutions the tub turned in that same 12-second interval, we once again can simply use our kinematic equations. This time, delta theta equals omega initial times time plus 1/2 alpha times time squared. Solving for omega, we find that the tub turned through an angle of 188.2 radians. The question, however, was asking for the number of revolutions. So we need to determine how many revolutions occur in 188.2 radians. Once again, I'll set up my dimensional analysis. I need a ratio of revolutions to radians. So I have 1 revolution per 2 pi radians. The radian units cancel, and I end up with 29.9 revolutions. Now, part D of this question wants to know about the centripetal and tangential components of acceleration of the washing machine tub, as well as the magnitude of the total acceleration, just prior to opening the lid. So what we've done here is drawn the centripetal and tangential components of acceleration, remembering that the centripetal is always along the radial direction and the tangential is always in the tangent direction. Let's quickly remind ourselves what omega and alpha are just prior to opening the lid. We can simply calculate the centripetal acceleration to be omega squared r, finding that we get a value of 197.2 meters per second squared. The tangential acceleration is r alpha, and we calculate it to be 1.6 meters per second squared. I can draw these 2 components of the total acceleration, and because the centripetal and tangential components are 90 degrees to one another, we can simply use Pythagoras to determine the magnitude of the total acceleration vector. So the square root of the magnitude of the centripetal acceleration squared plus the magnitude of the tangential acceleration squared gives a value of 197.2 meters per second squared. And that's it. Thanks for watching!